Unit 1 Chemistry, Chapter 2, looking at the periodic table and some of the properties of the elements within it. So there's a few things within the periodic table, whereas we go either across a period or if we go down a group, we see a consistent trend, as in it's always increasing or decreasing. It doesn't necessarily affect every single element in exactly the way we'd expect, but there's a distinct way we'd expect it to happen. So these are the ones that we're going to be looking at. Some of these may be familiar terms, some of these will be unfamiliar. First one we're going to look at is core charge. Now, core charge is a way of measuring basically how much the outer shell electrons, the valence electrons, feel the nucleus. Okay? They feel the nucleus basically because it's positively charged and they're negatively charged. But if there are inner shell electrons, they act as a shield. So they stop it feeling it as much, basically. So we can calculate the core charge by taking the number of protons and taking away the number of inner shell electrons. Essentially, it works out to be exactly the same as the number of outer shell electrons, but that's technically how you calculate it. So lithium, 3 protons, 2 inner shell electrons, 3 minus 2 is 1. So the core charge is going to be equal to the number of valence shell electrons, which means as we go left to right across a period, the core charge increases. As we go down a group, they've all got the same number of outer shell electrons, so core charge stays the same. Now, because of the core charge changing, that has an impact on the atomic radii. Okay? So, the bigger the core charge, the more the outer shell electrons feel the nucleus, which means the more they're attracted to the nucleus, which means the more they're pulled in and the smaller they get. So here we have ones with an a core charge of 1, which have got a relatively big size. As the core charge doubles, the atomic radius shrinks because those outer shell electrons are much more attracted. And as we keep going across, we find that it goes down and down and down. Okay? As you go down a group, the core charge stays the same, but the atomic radius gets bigger. That's because we're adding another shell each time. When we add another shell, it's going to increase the size of the atom. And that happens in every single group as we go down it. One more shell, bigger electrons. Notice amongst your transition elements, there's nowhere near as much change in size as there is, say, amongst your group 1 elements. Okay, so if we were to plot it, we would see that we go across a period, goes down, we go to the next group and it shoots up. And then it goes down, 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 and then it shoots up again.